Welcome back, everybody. Welcome back. This is another exciting adventure in the world of calculus. This is a assignment to be or not to be. That is the question. This is assignment 2B, and again, this is dealing with limits. Limits is the name of the game. This is more of a graphing assignment as opposed to an equation assignment. So let me give you the brief rundown of limits as far as graphing is concerned. All right, so what you really need to look out for when you look at a limit, as I kind of explained yesterday, the point itself, right? The point itself doesn't have to be in line with the picture. Whether there's a point there or not, it doesn't even matter. Like I have here, I have a point existing in a completely different place. I have my limit, let's say that's 3, and let's say that's 5. So the question that would be asked here, what is the limit as x goes to 3 of my f of x? And so again, it doesn't matter. What a limit implies is, what do the lines tell you? And so as I go to 3, what does the line to the left of the 3 say? And here is the line, and the line is saying that. What does the line to the right of 3 say? Well, the line to the 3 is pointing at that. So where are these arrows pointing? The arrows are pointing right there. That's where that limit is pointing at. Whether there's a dot there or not, it's not important. The limit is where the lines imply the point should be. So that line should be at 5. Now, if you were straight up asked what is f of 3, then there needs to be an actual defined point. In that case, that is the actual point itself, which is at 1. Okay, so the limit is the lines leading up to the dot. Now, when do limits not exist? Like when do you not get an answer for a limit? And limits do not exist when you have, let's say you have 2 lines, but they don't imply the same point. Like, so what's the limit as we go to 3 here? Let's say that this is 1 and this is 4 or something like that. And so the limit from the left-hand side says that, oh, that should be 4. But the right-hand side says, oh, no, that should be 1. So what is the limit as x goes to 3 in this situation? It does not exist. Abbreviation DNE. It does not exist. The limit does not exist in this situation. All right, so that is a situation where it doesn't exist. Depending upon who you ask, or when you ask it, what happens if you have a picture that does something like this? All right, so let's call this 3 again. What is the limit as x goes to 3? Again, that does not exist. There is, this one says it should be at infinity. This one says it should be at negative infinity. Technically, an infinity is not a limit. Like, so again, depending upon when and where you're asked, you might have to say which infinity it is. But here, if it goes to an infinity, what is the limit as x goes to 3? In this case, this is absolutely does not exist. Okay, absolutely does not exist when it goes to an infinity. Does not exist. All right. I haven't done the assignment just yet, so I'm sure I'm missing a few, but I'll try to talk about those examples as we see them. Okay, So a limit is, in essence, the lines leading up to the point, not the point itself. So in this equation, using the graph, what is the limit as x goes to 3? So here's the 3, the left-hand side points there, the right-hand side points there. They both point at the same spot, and so that is equal to 1. Number 18, going to 0. So going to 0 from the left, from the right, they both point at the same thing. They both point, I'm assuming that's at 1. So again, that's 1. Okay, here we got a closed dot and an open dot. Right here, they're asking when is the limit going to 2. So the left and the right, again, they point at the same thing. Okay, again, it doesn't matter if there's a dot there or not. They both point at the same thing, and they both point to 2. Here we have a dot and an open dot. I'm assuming, yeah, that is the question. So 1. So here's the line leading up to it. They both point to the same thing, and that is at, what, 4. The absolute value as a fraction going to 2. The left points to -1. The right points to +1. They don't point to the same thing. Does not exist. They don't point to the same thing. Okay, this wacky graph going to 0. So the left says it should be at 2. The right says it should be at 0. They don't match. They don't point to the same dot. That does not exist. So pretty basic when it comes to the actual graph. They're pretty easy. The arrows, the 2 lines have to point to the same thing. Okay, decide whether the value of the given quantity exists. If it does, find it. If not, explain why. The why would be, they don't point to the same thing. Okay, so letter A is actually, it's not a limit. It is an actual point. So looking at 1, is there an actual point somewhere on 1? Yes, it's right there. There's the actual point. And so the actual point is at 2. That's where the actual f of 1 is. Okay, letter B is the limit as x goes to 1. So the left-hand side says that, the right-hand side says that. Notice how they don't point to the same dot. That does not exist. Okay, why doesn't it exist? Well, again, they don't imply that they're going to the same darn thing. All right, f of 4. So again, look at 4. Is there an actual dot anywhere on 4? No, there's no actual dot anywhere on 4. So this actually does not exist. It is not defined at 4. It does not exist. The next question is asking, well, what is the limit as we get close to 4? Well, the left-hand side says this, the right-hand side says that. Notice how they do point to the same thing, and so that would be equal to 2. Ooh, a lot of questions on this one. Great, here we go. First question is, what is the f of -2? Looking for a concrete dot at -2. I don't see any concrete dots. There is no concrete dots. There isn't, like, you know, a dot like somewhere in existence, somewhere on that line. A limit as x goes to -2. This goes to -infinity, -8, sorry. This one says -infinity. This one says infinity. Bottom line, they don't point to the same thing, or to double up on that, they point to an infinity, which is in essence the same thing. It does not exist. f of 0, so looking at the 0, I see that there is indeed a concrete dot right there. So where is the actual point? The actual point is at 4. Limit as the lines go to 0. The left says it should be at about like a 1/2. The right says it should be at 4. They don't point to the same thing. That does not exist. F of 2, is there a concrete dot anywhere on this 2? This is an open dot, so that doesn't, there's nothing there. No, there is no point at 2. There is no point at 2. What is the limit as it goes to 2? The left-hand side says it should be 1/2. The right-hand side says it should be 1/2. They agree. It should be 1/2. 4. Where is the concrete dot at 4? So looking at 4 here, I see the concrete dot is actually at 2. Switch to purple. Is at 2, because there's an actual dot there. What's up? What is the limit as it goes to 4? So this left-hand side is pointing at infinity. This right-hand side is pointing at infinity. Even though they both point to infinity, infinity doesn't exist. So again, depending upon when this question is asked, the question could be infinity, but that is the same thing as saying does not exist. So in this case, let's stick with the does not exist. Stick with the does not exist. Uh, 29, sketch the graph that satisfies the given values. There are many correct answers, okay? So f of 0 is undefined. So there, you're not going to find a dot on f of 0. All right, limit as f of x, limit as x goes to 0, it's going to be 4. So there's going to be nothing there, but a line is going to lead up and away from it. F of 2 is 6. F of 2 is 6. 1, 2, 3, 4, 5, 6. That needs to exist right there. And the limit as x goes to 2 is equal to 3. So there has to be a line leading up and away from that. So the lines have to go through the opens, and that rando dot at f of 2 has to be equal to 6. So there you go. There's that picture. F of 0 is undefined, so there is no dot at 0. As x goes to 0, it's equal to 4. So the line going to and from 0 is attaching to the 4. F of 2 is 6, so there's a concrete concrete dot at 6 when x is equal to 2. However, the lines leading to and from the 2 will be equal to 3. Okay, f of negative 2 is 0. F of 2 is 0. The line leading up and to and away from negative 2 is equal to 0. And the line leading up into 2 does not exist. There you go. Something like that. I don't know. We have, I don't know, anything crazy. As long as the lines leading up to and from the 2, it don't match up. That's really the key to that idea. Determine whether the statement is true or false. If false, explain why. Give an example. If f is undefined at x is equal to c, then the limit as x approaches c does not exist. That's false. Okay, the actual point and the limit have nothing to do with each other. That would be like a converse, that would be something like this. Or, something like this. If it's not defined at f of c, f of 2, or something like that, f of c is not defined, does that mean the limit is also undefined? No, that does, the limit can actually be something. Okay, false. Okay. If f of c is equal to L, I always think in pictures. F of c is equal to L. Okay, that actually exists. Then the limit as x goes to c is also equal to L. No. Again, there you go. You got a limit that doesn't equal the point. That is false. Something like that. They're totally independent. They don't have anything really to do with each other. Multiple choice. The limit of h of x is equal to x as x approaches pi. Okay, so what is the limit as x approaches pi? What is the limit of what is the limit of h of x equal to x as x approaches pi? Okay. H of x is equal to x. There it is. So what is the limit of h of x, quote unquote h of x? That is the same thing as h of x. What is the limit of h of x as x approaches pi? This is basic substitution. Sorry, I had to read it a couple times. My bad. Function. 10 divided by x to the fourth is given, blah, blah, blah. What is the limit as x goes to 0? So that is pointing, that does not exist. Consider the function. Which of the following is true? I'm going to humor myself here. So we got 3, 1, 2, 3. When x is x right 2, so this would be 1 going like that. And it would have come down here with a square root. And then we have x 6 minus 2x. So 1, 2, 3, 4, 5, 6, down 2 over 1. Down 2 over 1. Down 2 over 1. So I think they miss each other. So if I put in a y of 0, that would be equal to 3. Yeah, okay, so yeah, these are in line with each other, they're not at the same spot. Okay, the limit as x goes to 3 is equal to 1. Okay, so just independent. So 3 minus 2 is 1, square root of 1 is 1. Yay! That works out. The limit as x goes to 3 of 6 minus 2x is equal to 0. So 6 minus 6 is 0. Yep. No legal mathematics. The limit as x goes to 3 of f of x does not exist. Yes, that is absolutely true. It does not exist. The two things don't match up with each other. And so which one are true? 1, 2, and 3. Limits of continuity. Okay, this, pause here. So what we got going on right here is limits and continuity. Now you'll notice that on these questions you see this like C plus in here. What that implies is this. If I have a graph, and let's say this is the number 3, and this is 1, this is 4, and I have a line that does this. Something like that. Okay, so we notice that the limit as x goes to 3 does not exist because they don't match up. However, the limit as x goes to 3 with a negative sign on it is implying that it's coming from the negative side, the low side, the left-hand side, if you will. So the limit as x goes to 3, very specifically from the left-hand side, the negative side of the 3, implies what does that line independently say? And that sign independently says, oh, that's equal to 1. Likewise, the limit as x goes to 3 with a positive sign on it is implying where is it, what is the answer as it's coming from the positive side of 3, the plus side, the big side, the bigger than 3. So 3 bigger than 3, what does the line say it should be? The line says it should be equal to 4. Again, you're not worried about the actual point, you're worried about what is the line saying that it should be. So that's what a positive and negative is. A negative comes from the left, a positive comes from the right. Okay, so here we go. The limit as x goes to 3 from the plus is that one, and that is equal to 1. Limit as x goes to 3 from the negative, that's that line. That is also equal to 1. All right, if the limit from the left and the right are equal to each other, that implies that the limit of the C itself is equal to whatever they're equal to. All right, if they're not the exact same thing, the limit itself does not exist. Okay, that implies that the left does not match up with the right. So from the plus side, from the negative side, that means the limit is equal to 0. Okay, from the plus side, from the negative side, the two things are not equal to each other, so the limit itself does not exist. The left side and the right side have to point to each other. So for a limit to exist, you have to have the two arrows pointing at the exact same thing. Okay, that's it.